I'm Anne Riddell, and this is Science and You from Four Freedoms Park on Roosevelt Island. The science of engineering. Most of us go through our day and probably don't give it much thought, but engineering is crucial to our lives, from the basics of a morning commute to the potential for massive medical breakthroughs. Take everyday conveniences. Do you ever wonder how those things work, like your television and phone? Tinabeth Pina does, so she went to City Tech to get some answers.
Physics is all around us. In fact, it's actually the backbone of our everyday lives, from turning on a light, to talking on the phone, to you being able to watch me right now. And we wouldn't have engineering if it weren't for physics.
Physics law are behind of many development and many achievements which we have in engineering, in technology.
Professor Roman Kesharavili credits the discovery of electricity as the catalyst to the everyday living we take for granted.
Electric power, which is one of the most great achievements which we had in 18th century, So I cannot understand how we can live. For example, the iron. You have today electric iron. Just plug, after a couple of seconds, it's already hot and you can iron your clothes. What's happened before? You had something which you have to heat, wait, and after that clean, and then to iron.
We have things that were big in the 1940s we learned off of, and through the generations, it got smaller. So the technology has increased and condensed and got lighter and heavier from the heavier parts.
Electricity isn't the only discovery that has made our lives easier. Magnetism is another phenomenon that also plays an important role in our everyday life.
Electricity and magnetism will power the motors that run the device, that would function the device for you to function.
Electric current can produce magnetic field. And changing magnetic field can produce electric current. And basically, we have electromagnetic field. So there are sometimes things which working only based on the magnetism. For example, compass. If you have a compass, it reacts only on the magnetic field. There are devices like your iron, which works only based on the electricity. However, there are devices which are working with coexistence of electric and magnetic field. This is electromagnetic wave which your cell phone catching. This is electromagnetic wave which you using in your radio set in your car. There are electromagnetic waves which we producing in microwave by converting energy of electric current to electromagnetic energy, which has very short wavelengths, microwaves. Its energy is enough to use for heating or cooking.
It's that same electromagnetic energy that allows you to actually watch your favorite TV show through photons or light particles that are emitted through your screen.
Those light particles are being copied and then transmitted into electrical signals. Then those electrical signals are actually being turned into radio waves. Those radio waves are being transmitted to a receiver, and that receiver is picking up what you see and actually taking those electrical signals and those photons and showing you back into the image. It is.
People don't really realize how complicated the devices that we use on an everyday basis actually are, right?
Yeah. When you pick up your phone, you call somebody, you don't realize you're sending a signal out to a tower, to another network, so that network's person's network, so that person's phone rings and you can hear the person on the other line.
From phones to computers to whatever new invention is coming our way, technology has definitely changed our lives for the better.
Technology is actually bringing it to a point where you think it, now you can build it. The science behind it is how you make it all work and how you actually benefit the person and actually have benefit everybody around it. And that's what people are thinking about, how to actually make it more easier for people.
Only time will tell how physics will affect the future of engineering, but chances are it'll have a tremendous impact on our everyday lives, and we still won't even realize it. For Science and You, I'm Tinabeth Pina.
Moving around the east side should get easier for commuters soon, though it won't be ready until the end of next year. Construction on the 2nd Avenue subway is rolling along. Donna Hanover takes a look.
One of the greatest urban engineering challenges is building transportation below ground while life goes on as normal in the streets and buildings above.
We gathered on 3rd Avenue and 63rd Street at what will become a station entrance to the new T line of the 2nd Avenue subway. This is phase 1 of a 4-phase project that will eventually put new subway tracks below the city's east side from Lower Manhattan north to 125th Street and feature 12 new entranceways. Michael Haradnicianu, president of MTA Capital Construction, is an engineer by training and our official guide in a media tour of this massive construction site. We entered the site through the existing station at 63rd and Lexington, which will eventually connect with the new rail system. Engineers have installed nearly 9,000 feet of new track so far, much of it designed to be low vibration, insulated to act as a sort of shock absorber.
So does it make the ride smoother?
It will make the ride smoother, and it will have less of an impact on the surrounding buildings.
But the most striking thing to me was how these tunnels looked just 2 years ago. Then the space was a massive cave that was carved out of bedrock with dynamite. Today, much of the space is beginning to look like the transit system that will, by 2016, carry 200,000 passengers on a daily basis. Much of the infrastructure is in place. Elevator shafts have been cut. Electricians are installing up-to-date signal and relay rooms that are designed to interact with existing systems, and emergency water lines are now connected.
This red pipe along the edge of the tunnel contains water in case there's a fire, and the pipe above it is empty so the water can be removed.
But as with any project of this magnitude, engineering challenges lay ahead.
This is going to be the tunnel to Houston Street.
In the coming years, this now solid ground will be blasted out and bored through by a tunnel boring machine. The TBM is a marvel of modern engineering, 22 feet in diameter and over 450 feet long. The cutting heads alone can weigh 140,000 pounds. So far, engineers have mined out and constructed nearly 15,000 feet of new tunnels.
We actually had to put down pipes that were about 120 feet down. We had 2 chillers on the side, and we circulated a brine that actually froze the ground.
Ventilation and temperature control in the new stations will be regulated through a system engineers call air-tempered, which they describe with good humor.
Air-tempered means that it will be always 10 degrees below the outside temperature.
And how do you achieve that?
Basically having an air conditioning system that is not strong enough to air condition the station.
Engineers are always ready for the unexpected. Back up top, I asked Michael about a most unusual roadblock.
You had to use a diver at one point because of something you encountered? A metal piece or something?
Up north, where we did a cut and cover, we discovered that a piece of metal was left behind deep down about 100 feet.
A deep-sea diver had to slip down a steel tube and use an underwater blowtorch to cut away an old steel plate before the project could continue.
So that was kind of a fly-by-the-seat-of-your-pants challenge?
You had to fly by the seat of your pants.
This is where engineers will install a bank of escalators 174 feet high that will take passengers up and down to East 83rd Street. I'm Donna Hanover for Science and You.
Getting around over water is also an engineering feat. Building and maintaining our bridges requires an army of sophisticated thinkers. Mike Gilliam shows us what's involved.
What you're looking at will eventually be the new Tappan Zee Bridge. The first span is scheduled to open in late 2016 or early 2017.
But long before anyone could dream of an opening date for the Tappan Zee Bridge replacement, the planning began. Engineers looked at the environmental impact the new bridge would have, the geological conditions that needed to be considered, and who and what would use the span. David Capobianco, the project manager, says, then you decide on what type of span will get the job done.
The type of bridge is largely driven by the length of span that's necessary. So for this particular crossing, you have to break it up into segments. And And the only parameter that we gave to the design builders was that you needed to span the navigation channel.
The navigational channel is determined by the Coast Guard, which has jurisdiction over it. It's the deepest part of the river where ships going from the ocean to Albany travel. Capobianco says the channel is really like a huge envelope, 1,200 feet wide and 139 feet high, that must be protected so that large ships can make it through.
So we provided what the minimum span length was that the Coast Guard requires for the navigation channel, and that drove really the type of bridge for the main span.
It came down to a choice between a suspension span and a cable stay span. They settled on the cable stay bridge.
A cable stay bridge has cables that are tied directly from the steel edge girders to the towers, whereas a suspension bridge, there's a main cable that then suspends cables from that main cable down to the deck. So there's a little bit of a difference. Suspension bridges generally, or can, span longer distances. The Verrazano, I believe, is about a mile long between their towers. Cable stay bridges don't have that same ability, but they're a lot more economical in the shorter distances, which this is, about a quarter mile between towers.
Why the open tower design?
With the open towers, there's nothing over the roadway, no chance of ice forming on any bridge elements over the road that would have to be dealt with when the bridge is fully open.
And it provides more of an open feel. The rest of the bridge, which is close to 3 miles, will be more conventional steel girder construction with huge pilings. It'll handle a lot of weight, including breakdown lanes, a bike lane, and could carry mass transit at a later date.
It can handle a bus rapid transit system. It has the structural load capacity built into it to handle full Metro North commuter rail or a light rail system. So it is the bridge of the future that we're building right now.
A lot of the pieces are being fabricated upriver and will be brought down and placed into position here. But they're so heavy, builders had to bring in the Left Coast Lifter, a huge crane that's been renamed the I Lift New York Super Crane.
There's no other crane that has the capacity to lift those segments up in place. So that was quite an important element of being able to build the bridge in such an economical fashion.
The crane had to be brought in from California.
It was originally built for the San Francisco-Oakland Bay Bridge, and it was designed such that it could fit through the Panama Canal, and that was quite fortuitous because that's what they needed to do to bring it here to the East Coast. So they floated it through the Panama Canal, up the Atlantic Ocean and up the Hudson, and then finally to the Tappan Zee.
While the new New York Bridge is a testament to modern technology, the iconic Brooklyn Bridge, which opened in 1883 and spans the East River, is still a favorite among engineers and the public. Bridge engineer Khaled Mahmoud calls the Brooklyn Bridge the most beautiful bridge in the world.
I love the Brooklyn Bridge. You look at it, it's a bridge that's been in service since 1883. So today is was built 132 years ago.
The Brooklyn is kind of a hybrid that takes full advantage of suspension technology.
The load is delivered to what we call the bridge deck. That's the bridge flooring. It goes distributed to the set of girders and beams that support the flooring system. And then you have the suspenders, which are the vertical elements that pick up the load from the roadway, delivers the load to the main cables, and the main cables in turn take the load into the tower on one side and into the anchorage on one side.
Bridge building has not always gone as planned. The first Tacoma Narrows Bridge opened on July 1st, 1940. Nicknamed Galloping Gertie because she twisted and shook in the wind, the third largest bridge at the time, behind the Golden Gate and George Washington, collapsed into Puget Sound 6 months later under stress from 40-mile-an-hour winds. Now engineers consider lots of things when building the superstructures.
You consider the span length, the materials that you're going to use, the limitations because of seismic activities or wind action, and you do what we do now. We build a model of the bridge and we subject it to testing in what's known as one tunnel test, and all these issues factor in the process. How long it would take you to design the bridge and construct it, what construction techniques to be used. So a lot of factors that get into the process.
And while it's difficult to deal with all the weight involved in bridge construction, Mahmoud says don't expect a major shift to lighter materials. Steel and concrete are the backbone of the structures.
You cannot negotiate with gravity. So the weight is a big part of a suspension bridge. Actually, most of the load that we design cables for, that we design the towers for, is coming from the own weight of the structure. So it is the nature of the beast, if you will.
Back at the new New York Bridge, the Cuomo administration has worked to limit noise and other disruptions to nearby neighborhoods and worked to make the whole project more accessible by setting up viewing stations where the public can observe the construction.
Right behind the Tarrytown Metro North Station, there is a viewing platform that has high-tech binoculars out there, a spotter's guide that explains what the equipment is and how the construction is going to be sequenced. Very popular with school kids and other groups. We've also created one at Nyack Memorial Park in Nyack on their new fishing pier.
Now, if you're into big landmark projects like this or engineering, you might want to come and check out this construction. We may never see another bridge project this large in our lifetime. I'm Mike Gilliam for Science and You.
From the science of the everyday to what sounds more like science fiction. What if there were no more wheelchairs and people paralyzed, say from a spinal cord injury, could walk again? It might just be possible with a new generation of robotic devices. Dr. Max Gomez explains.
Every year, 12,000 people suffer a devastating spinal cord injury. In the U.S., there's more than 250,000 people who are living with paralysis due to that kind of an injury. For most of them, their dream is to one day walk again. And now, for some of them, that dream is starting to come true.
Immediately after the car stopped, I went to move, and everything was pins and needles. Nothing moved, nothing responded, and all I felt was pins and needles from the waist down. So it was pretty much right away. I knew something was different.
That car accident coming home from school left Gregory Shepard paralyzed from the waist down. It looks and sounds kind of like something out of RoboCop, but this is not science fiction. It's a reality that Greg Shepard could only dream about for the past 30 years.
Every person that goes through some type of disabling injury, a traumatic injury, they literally spend most of their days thinking about when they used to be able to walk and when they're going to walk again. And it's just, you're just spinning your wheels, literally waiting until that happens.
What allowed Greg to take those first steps in so many years was a device called an exoskeleton, a complex series of electric motors, batteries, computer controls, and algorithms that are truly engineering marvels. Seems that walking is far more complicated than most people realize.
It can be described as a controlled fall, that you have to shift your weight onto one foot in order to be able to swing and clear the other foot, and then in putting that foot forward, you're essentially controlling the fall of your center of mass forward. And to do that repeatedly, again, with a changing environment, not a simple task.
The exoskeleton isn't doing all the work. It's a coordinated interaction between man and machine that takes time and a lot of effort to learn. That's why there's always a physical therapist right behind the patient.
It's overwhelming. It's amazing. It's just overwhelming. It's 16 years, and I took my first steps 2 weeks ago. So, you could imagine it was really breathtaking.
Sergio Urias was paralyzed in a diving accident that he was lucky to even survive. He's using one of a couple of different types of devices as part of a clinical trial.
I saw somebody, walking in the hallway, and I'm like, "What's that? Can I participate? Can I help? Can I do this?"
But much as walking again is an emotional experience, researchers know that there are very real physical benefits as well. Seems our health is closely linked to moving.
If we get up and move, we stimulate circulation, we burn fats, we generally live a healthier life. We also can improve breathing, so we move air in and out of the lungs. We're at less risk for for lung infections and things like that. And you get your bowel and bladder moving and all of your internal organs. So life in general becomes a whole lot easier to do.
Finally, there's something else exoskeleton users appreciate about standing upright again.
The person that's in the chair like myself, not just having to constantly look up at somebody, but all of a sudden everything wasn't above me. You know, when you're in the chair, you're down around at people's belly buttons, and all of a sudden you're looking people in the eye.
So what does the future hold? Well, the engineering challenges, making the devices smaller, lighter, more responsive, the batteries more powerful, those are problems that will be solved. The bigger issues are cost and access. Who's going to get the devices, and how will we pay for them? Those are societal questions that will be much tougher to answer. For Science and You, I'm Dr. Max Gomez.
As a topic, engineering sounds complicated and maybe a little bit intimidating to some of us. Enter littleBits, essentially electronic building blocks that allow even kids to create sophisticated circuits and tap into their inner inventors. Beth Kovetz has more.
The do-it-yourself movement is expanding the creative world, but today it's kind of stopped short at electronics. Creating electronic circuits still falls into the realm of the expert. What if you could create sophisticated electronics of your own design by snapping together modular circuits as easy as building with Legos?
Based in Chelsea, a company called littleBits has created kits of prefabricated electronic circuits that snap together without soldering or programming.
The mission of littleBits is to put the power of electronics in the hands of everyone, and we make electronic building blocks so that anyone can build, prototype, and invent with electronics.
Sounds great, right? We took this new technology to Michael Zottolo's high school science classroom to see what they thought of it.
I've got a set of materials in these bags, and all I would like you to do is make something. No other further instructions other than that.
Mr. Zottolo gave the kids 10 minutes to just explore the circuits and see what they came up with on their own.
Very nice. Awesome. Let me bring everybody back. You've just had your first experience with littleBits. If you guys noticed, how did they snap together? It's great. There's magnets there, and the magnets are arranged in such a way that they will only connect, the two littleBits will only connect in the way that they're meant to connect. So this is great for especially people who have no circuitry background. There's really no danger in possibly connecting something or creating a short circuit. Now, just let me put this into the big picture. These are great for coming up with the prototypes for designs. What we create today, you might want to use later for your final project, where you build a real system, and we're going to use circuitry material that engineers would use based on designs that you create with these.
littleBits were created in 2011 by MIT Media Lab graduate Aya Badir. Badir is a significant force behind the open-source hardware movement aimed at making designs publicly available to be modified or distributed by anyone interested in electronics. And although she's only 33, Badir has racked up an extraordinary resume of awards.
She's inspirational to work with. She's amazing.
Most of the products that are so central to our lives are electronic in nature. Understanding how they work is an important part of a kid's education.
I think they're awesome because you could create so many different projects. I felt pretty smart when I was doing it myself.
We really view ourselves as a 21st century learning tool to learn anything, to learn electronics, to learn design thinking skills, systems thinking, to learn about how technology around us works. So I think education is really at the heart of everything that we do.
And littleBits could have settled anywhere. Why settle in Chelsea?
You know, a lot of people actually ask us why we're not in San Francisco, and I think it's because New York is at this intersection of so many amazing, cutting-edge fields that's where we want it to be, because we really view ourselves as a tech tool for everyone, not a tech tool just for tech enthusiasts.
From School of the Future, yes, that is the real name of this school.
This has been Beth Kovetz for Science and You.
When you think of the Girl Scouts, what comes to mind? Maybe cookies? Maybe badges? Well, there's a lot more going on, including getting young girls excited about science, technology, engineering, and math. This Brooklyn Brownie troupe has a critical mission underway.
We're building the arm of the robot, and I think next we got to do the brain.
What will the brain do?
It will make it like to go backwards, make it to go forward, make it to go sideways, make it spin.
This is not your mother's Girl Scouts. For these brownies, the experience goes far beyond the badge. It's an all-out effort to get young girls engaged in STEM, science, technology, engineering, and math.
We wanted to encourage the girls to think about things other than what girls might traditionally be geared towards. Engineering and the sciences are so important in today's economy, and I know I'm thinking ahead for our girls, but I really wanted them to feel comfortable with it. And I thought, what a great way to feel comfortable with science and engineering than to build a robot. All the girls here love Legos, and what it really is Legos added with a computer overlay.
I like science because I like seeing if stuff works. If things work.
But for too many girls, that early enthusiasm doesn't seem to translate into the workforce. Take a look at these numbers. Women make up 47% of the total U.S. workforce, but are much less represented in some science and engineering occupations. For example, 39% of chemists and material scientists are women. Only 15.6% of chemical engineers are women. And that drops to just more than 8% when it comes to electrical and electronics engineers.
STEM careers are growing. It's definitely, in all STEM fields, they're growing, and we want to prepare our girls for that workforce when they get older.
The Girl Scouts have done research of their own. It finds girls like STEM topics. An overwhelming 74% of teen girls say they're interested in STEM. So what are some of the potential gender barriers? More than half of girls, 57%, say girls their age don't typically consider a career in STEM. And almost half say they'd feel uncomfortable being the only girl in a group or class. One way to beat those obstacles? Start early, before ideas of what girls can and can't do take root.
Girls can do anything. They can be anybody. And when you catch them now, I think it's such a perfect point because they're so curious about everything.
I already planned that I wanted to be a geologist.
In addition to robotics, the Girl Scouts are offering programs like web design and digital movie making. That's our show for today. Join us next month for an episode you and the women in your life won't want to miss, an in-depth look at women's health issues. I'm Anne Riddell. Thanks for joining us for Science and You.